Guys, next write down. Next topic name is Lenz's law. Lenz's law, a consequence of conservation of energy. This is compulsory 2 marks question, and based on that you can also get a questions in a NEET also. Okay, so this year's a slight touch was there for the Lenz's law. Okay, so what is it now? Put a heading once again. Lenz's law, a consequence of conservation of energy. Conservation of energy. Very simple, and this law is very important, and you can say that a 2 marks question in a NCERT based. Okay, board wise it is 2 marks question it will come, or else it may come for a 4 marks in the NEET exam. NEET and JEE same thing here. So now what is it now? Logic you should understand. Like for example, you might have seen some videos in YouTube also. Now for example, there is a coil, like for there is like this one of the pipe. Okay, very big cylindrical pipe like this, right? Upon this one you have a windings, wire windings. Now for example, now what I'll try to see is like this, the windings are there, the current which is passing through this one and going from this, right? Now whenever, like for example, if you try to if you are trying to pass any conductor through it, what happens, buddy? So it will be like, already what is this one here? This is a solenoid, right? Yes or no? So through this one, for example, you want to pass one of the conductor, like one of the conductor in the sense one a magnetic material like iron, something like this. You want to pass through this one. Whenever it passes through this one, it comes to the velocity v inside this. So whenever you drop it, a freely falling body, same sort of like one more same with the same height I am trying to take. One more conductor of identical conductor. Now like this. So the same conductor, this is conductor 1 and this is a conductor 2. Now it is also falling down with the, okay, falling down. Now which one will reach the ground faster? Now if there is a ground here, like logically let's understand this is a ground. Which one will come down? First one or second one? Think and tell me. First one or second one? This is freely falling and this is passing through the, what is that here? A solenoid. Okay. Now tell me which one will fall down first? First or second one? Huh? Second one? First one? Say it, Neharshini. Second one. Huh? Yesterday, Lenz's law, what did I tell you? It will oppose the motion of the conductor. Yes, and it will oppose the motion of the, what is that here? You can say solar magnet or whatever. Now, for example, if there is no current is also passing, if there is no current also here, and if this is a magnet, what happens? Which one will pass now? Faster? Which one will pass? So this is a freely falling. It does not have any effect. Yes, and it will fall freely due to the gravitation. But this one will have some effect on it. Why? Because this will try to oppose. This one try to oppose it. the motion will be opposed by this one. That's what the Lenz's law, right? So Lenz's law, what it will try to say? So induction of the field will be there, induction of the pole will be there. Yes or no? For example, if I try to take, this is the north pole, this is the south pole. Like for example, I'm trying to take here. There is no current inside this coil, no current. Okay, but this is a magnet. I am taking, what is this one here? Let's imagine instead of conductor, I am taking here magnet. Let's say magnet, right? Are you getting my point here? Magnet in the sense, let's say north pole, here is south pole. Here is north pole, here is south pole. Now magnet is falling down. Now magnet is falling down. This magnet will reach like a freely falling body only. But what about this magnet here? So it will try to oppose. Why? Inside this one, what is this one here? Inside this one, there is a automatically, if it is north, na, here also it will develop north. Here also it will develop, what is that here? South. Yes or no? Whenever it is going towards it, more number of field lines will be passing through this area or not? Yes or no? More and more means if you increase the field lines passing through the area, you increase, what is that here? Flux also. If you increase the flux, what happens here? EMF, induced EMF will generate or not? That's what I told you, right? So what is the induced EMF formula? If you could remember, induced EMF is equal to minus N into D flux d pi divided by dt. Did I tell you or not this thing? Yes or no? If the flux is increasing or decreasing, EMF will be induced in opposite direction. So this magnet will be opposed. Yes or no? So this magnet will be, what is that here? Opposed. So which one will be coming down faster? Second one will be late. First one will be coming faster because no effect. Yes or no? So I am writing that only. So second magnet will come down after some time. After some time, or you can say it is coming down with a late. Is it clear? So why? Because an induced EMF, an induced means what is that? Generated EMF will generate. I told you all. Induced EMF will oppose the motion of the conductor. Okay, we know that motion of the magnet. Am I correct here? Magnet, right? Yes or no? But what is this one here? But our topic is, what is that here? Our topic is consequence of conservation of energy. Yes or no? Now, for example, here I will try to tell you as a flowchart based. I will try to tell you. You can frame it as a words also, right? For example, you see the magnet. So stage 1, stage 2, stage 3. Can I take it like that? So stage 1 la, what is that here? Magnet is at certain height. So it is possessed with which energy? If it is at height, now which energy it will possess? Potential energy. Yes or no? Now, so magnet has which energy now? Magnet with a potential energy, which is simply I'll write a P at a stage 1. At stage 2, you tell me. Stage 2, what is the stage 2? Inside what is that here? Inside the solenoid, or simply say pipe or whatever. Okay, or you can say pipe, conducting pipe basically. It should be made with metal, right? Now inside this pipe, what is this here? Potential energy is converted into what is that now? Potential energy is converted into what is that here? Electrical energy. What is the energy it will convert it? What is electrical energy? Yes or no? Because energy can be converted into one form to other form. That's what a conservation of energy or not. Again, what is that here? In a stage 3, what is the stage 3? Now this magnet is leaving the pipe. The magnet is leaving, what is it here? The solenoid or pipe. So magnet leaving now, what is this here? Magnet is leaving. Then electrical energy will convert into what is it here? Heat energy, and it will vanish. Are you getting my point here? So electrical energy will be converted into what format, buddy? It will be converted into heat energy. So you see, earlier this magnet has a potential energy. You are dropping into the pipe, as a conducting pipe or solenoid. Okay. So whenever it is dropping down, what happens here? Automatically, a north will be generated. So what is the current here? Automatically north means anti-clockwise current will generate or not. So inside this coil there is anti-clockwise current will be generated like this. So this will not allow that the magnet to pass through it. It will oppose it. Yes or no? It will oppose it. So whenever it is opposed here, what happens here? So magnet earlier has a potential energy coming down with a kinetic energy. Of course, it is coming down. Now what is it inside the solenoid? It will be converted into what is it here? Electrical energy. Yes or no? And then whenever it is leaving, what happens? This electrical energy is converted into what is it here? Heat energy. Yes or no? So if you could say this law is a consequence of conservation of energy or not. So during their conversion, what happens here? The magnet will be opposed. Clear? Huh? Can you write it down now? Note down. Here the galvanometer will deflect it. That's how we sense the current. Finished? Did you finish it? Next, one line you can add here, buddy. What is the line, na? Did you finish it writing part? The stage 1, stage 2, stage 3? Right. Now, so next, if I try to say one line, write down one line, that is the work done in moving the magnet, the work done in moving a magnet through the coil or solenoid or a pipe, you can say, is converted into what is that word? Electrical energy. This energy dissipated means lost. Okay, dissipated in the form of heat energy. Dissipated in the form of a heat energy in the coil. Okay, therefore the induced current always flows in such a direction to oppose the cause. Okay, hence it proves Lenz's law is a consequence of what is that here? Conservation of energy. Okay, so you should understand this one. This point you always need to add. The energy is dissipated in the form of what is that here? Heat energy. First, what is that you are doing here? The work done in moving a magnet through the coil, okay, converted into which energy here? Electrical energy earlier. After that, what happens here? When the magnet leaves, that will be converted into heat energy and it will leave. That's it. Okay. Whenever it converts into heat, what happens, buddy? It will give it to the surroundings. That's it. The energy will be dissipated. Okay, so why that is happens now? This induced current, whatever the current was generated in the coil, which is always opposite the cause, because this induced current is caused, means the induced current is produced because of the magnet movement through the coil, yes or no, right? So this automatically it will oppose, because that coil whenever the magnet is coming now, here it will develop north, here it will develop south, yes or no? So whichever side is coming, that side it will develop the respective poles, right? Next, what is the Lenz's law? Lenz's law is always what is that here? It opposes the induced current or induced voltage opposes the curse. That is what we studied already. So hence it is proves the entire example will prove what is that here? Lenz's law is the consequence of a conservation of energy. Damn sure this year also this question will come. Okay, so you should be very careful with this. Shall we move on now? Okay. So yesterday we already studied a cause of EMF, right? Next, write down, buddy. Next topic name, induced parameters. Did you finish? Next heading is what is that here? Induced parameters. Okay, this thing's already there in your book also, but once you should go through it. So what is a Faraday's law or Lenz's law will tell you. So Faraday's law, the Faraday's law is simple here. So I'll try to show you. First we'll talk about an induced EMF. Induced EMF, which is denoted with the E. What is the Faraday law says that EMF induces means EMF will generate, okay, whenever there is a change in flux with respect to time. Am I correct? Change in respect to time. Now, but Lenz's law said that this EMF will generate always opposite to it. Am I correct? So if the n number of coils are there in that particular n number of coils are there in that segment, na, what is that here? Minus n d flux, d change in flux divided by change in time. Can I write like that? Yes or no? This is what is this one? This one is an instant. Whenever there is a differentiation, what is that here? Instant EMF means instantly you will have a EMF. Instantaneous EMF we can call it. Induced EMF we can call it. Or else we will also have one more EMF also, which is average EMF. Average means AV means what is that here? Average. So average EMF is n into, instead of this differentiation we'll use the delta pi divided by delta t. Yes or no? Or else minus n into what is that I can write here? Pi 2 minus pi 1 into divided by what is that here? T2 minus T1. I can use it. So average is also there and instantaneous is also there. Mostly we'll use the instantaneous. Right? How did you get it here? Whenever there is a flux changes, increment, decrement of the flux yesterday we discussed. If we do that, now automatically EMF will generate. That's it. Next, second parameter is induced current. Okay, induced current. Induced current. What is the induced current here? Simple here. So, for example, now whenever you are generating a EMF, if you divide with the resistance, then it will become what is that here? Induced current. So, if I say this formula will become now what is that here? Minus n divided by R and the d change in flux divided by change in time. Yes or no? Note down. Next, induced charge also there. Induced charge. So what is the induced charge here? So this instead of this I, I'll write a Q. dq by dt, can I write it? So I'm trying to write that only. Induced charge is nothing but what can I write now? This is we already knew. I is equal to d pi divided dq divided by dt, which is nothing but a, what is that, right? Which is nothing but a minus n into d pi divided by dt. Yes or no? I'm just replacing with the dq by dt. So if I cancel dt and dt na, from this one, what is the left out part here for you? That is a dq is equals to, we'll have it as a minus n into d change in flux. Yes or no? That's it, right? And divided by r also there. Please, you should not miss that. Here also r also there. Right? Huh? So that will give you what is that here? Induced charge. Induced charge means you are influencing the charge in the other coil. Then, so just now we studied about heat also generates. Yes or no? Am I correct? Heat also generates or not? So that heat, induced heat also we can say. What is this induced meaning actually? These are all generation. Yes or no? We are trying to generate all this. Shall I move on further? So have you seen a typical heater? Heater have you seen at home? Will heat water, right? Normal heater will be there, no? So it will be like a coil. When you place it, it automatically generates what is that here? Instant heat. That is an induced heat only, right? Shall we move on to that? Did you finish it? Next, write down last parameter here, which is induced heat. Next parameter is what is that here? Induced heat. Yes or no? Induced heat. What is the induced heat? Heat is equal to what is the formula, buddy? Heat is equal to which is the formula? If you are doing a heat is equal to small heat you are taking, na, dH is equal to what is it? I square R into T. But here I am taking this T as a small t. Can I take it like that? Small dt. Means within a small time you are actually getting what is that here? Small heat you are getting. Right? So H if you integrate on the both the side. So H is equal to what I'll get it here? Integration of I square R dt you will get it. RS, no? So you replace all the I you already have in your hand, R you already have in hand, T already you have. So just integrate it, you will get the answer for it. No? Or sometimes you may get a heat generated by the coils like that they will ask you questions, which is a T1 time to T2 time, I square R into dt. Use this one, you'll get the answer. Done, buddy. Is it clear? Shall I move forward? That's it. So how many things you can generate? Whenever you change a flux, you can change. You can generate a EMF. You can generate a current. You can generate a heat. You can generate a charge also. Yes or no? Those are all called as induction. Yes or no? Induced. Induced means what is it here? Created. Now I'll tell you, this word can be used in history also. You might have studied. What is that here? Induced famine by the Britisher in a Bengal. You know Bengal, right? So before the World War, there was a very big famine. Yes or no? Have you studied that in history? Induced means created. So this Britisher people plunder all this wealth from India, okay, all the fruit grains, and they'll ask us to cultivate the indigo. That is there in your one of the chapter is also there, indigo, right? So there, so instead of all the food grains is all taken by the Britishers, right? And only nothing is left to eat. So people died with the hunger in the Bengal region, in the Bengal province. Okay. So induced means created one. Okay. Shall we move on further? Now we will say about a note. Note. What is a note now? For example, I am talking about a note here, which is electrical inertia. Electrical inertia. Right now? So this inertia term, if you could understand well now, half of the physics you already understood. Okay. So what is the inertia? Generally, we have studied already inertia, right? Yes or no? What is the inertia? Tell me what is the moment of inertia? Moment of inertia is simple, buddy. You have to remember, if I want to rotate some wheel, earlier when I want to rotate a wheel, it is easier. No, it's difficult. Means the starting also difficult. Now, whenever you started rotating, you want to stop it. Then also it will be difficult or not. Means it will not allow us to start. It will not allow us to stop also. Such property is called as electric inertia. Now we are talking about what is that here? Electrical inertia. Okay. So electrical inertia, how we create it. If you could understand this one, the upcoming days, it will be very easy for you. So in this one, let me talk about a case one. What is that one here? Case one and case two. What is a case one? For example, I am connecting one of the solenoid. So now onwards, we'll not call the solenoid, but we call it as an inductor. What do we call here? Inductor. So inductor, what is that here? Inside this one, for example, I'm actually adding one of the battery here, or you can say cell. I have cell, okay? Cell I'm connecting. So now what is that here? In this is one case. And the second case is that, and instead of only a single thing here, I wanted to increase, decrease the current. Okay, I wanted to increase, decrease the current. So for that, I'll have a, what is that? I'll have one of the rheostat connected at this point. So this setup, you know already rheostat. Yes or no? So rheostat will fluctuate the current into the circuit. So same thing here, case 2 also I'll try to take it here, same type of diagram. One is increment of current, one is decrement of the current. I'll try to take it. Okay, same sort of diagram with in a, what is that, rheostat setup. Okay, buddy. So two basic circuits I am taking here. And now you see, for example, inside this one, what is the current here? The total current is passing through this one is I current. But what is this happens here? This solenoid will try to oppose the current. Whatever the current is coming here, this small I will try to oppose it. What is this I here? This I is a induced current. What is this one here? Induced current. So it will not allow, because you know already you studied the moving charges and magnetism. Whenever current is flowing through the coil, it becomes an electromagnet. Am I correct here? But this induced current will not allow to become a more stronger magnet. Yes or no, Ashwin? Going somewhere? Okay. So now in this situation, what is it here? We are increasing. Okay. So here, one important point I would like to write. If I wanted to increase the current here, what happens here? I also try to increase. It is tries to opposite in a stronger manner. Okay. Are you getting my point here? Now same situation I am creating here also. where positive, negative. The total current here is I. Now here what happens here? I am trying to do what is that here? The current I am trying to reduce with help of a rheostat in the circuit. If you reduce now, what is the current inside this one here? Induced current. That is also not possible for us. It will oppose that also. Okay. So here what happens if you try to reduce now? It will not upward. It will not allow to reduce the current instantly. So I, what is it happens here? It will try to increase in opposite direction. Okay. So what is this I here? So I oppose the reduction of current I. Are you getting my point? It will not allow us to increase. It will not allow us to decrease also. So it is sort of what property is this one? Inertia property or not? Yes or no? So here I, what is this I here? Oppose the increment, so increase of capital I. Here it is also opposite. Here also it is opposite. What sort of property is this one here? It is a electrical inertia property. Got it? So whenever you are increasing, it will oppose. Whenever you are decreasing, it will oppose. Both the ways it will oppose. Clear? Are you sure? Yes, of course. This is what happens in the EMI. No doubt.